So, in this video, I'm going to show you how to create an attractor point pattern using a line. To get started, I create a hexagonal pattern. Is- And then I want to actually scale this geometry, and this gives me the center point. So the center will be like this. To create the attractor point effect, I should give a variable factor. To do that, what I'm going to do, there are two ways. I can create like a geometry, a curve in Rhino, like this. And say, and then drop a geometry and say, set this geometry and take this. I can also internalize the data. And then the next component I need to drop into the canvas is the pull point component. And the pull point component actually takes a list of points, like a cloud of points, and then you give this geometry and say, okay, now what is the distance between all of these center points and the points on this line? Okay, and then based on the distance, you can give a factor. So what I'm going to do, I'm going to create a bound of number based on the distance. So I say, get this list of distance values and create a domain of a numeric domain of from the least to the most. And you can just simply connect it to this factor, but that really doesn't help because sometimes the distance is too low or too high that doesn't let you create a meaningful factor. So in order to fix that issue, you need to map the numbers. So I'm going to say, okay, take these distance values and take this source domain and convert it to a domain between 0 to 1. So in this way, we want to take the list of the numbers we have from least to the most and remap them to a scale between 0 to 1. So that's how we're going to fix that issue. So to give a target domain, we need to construct domain. Construct domain. And that is a target, so we should give a number. So I can say between 1 and 0. So and since I need 2 decimal places values, I'll 2 digits. All right, so now I can connect this mapped number to the factor. Now, look at it. Based on proximity to this line, these numbers can, the factors can be different. So I'm going to play around with these factors. And then you can see how this pattern can be nicely generated. Another way to create this effect is that to define a parametric curve. So you can create a parametric curve in any ways, or there is another way if you, for example, want to make this pattern based on the proximity of these center points to one of the edges of this rectangle. One other way to do that is to call bounding rectangle. And you're going to have like a list of the cells. So this bounding rectangle is supposed to take the geometry, put a rectangle around that. Right now, this geometry is defined as a series of strips. So that's why we're going to have a series of rectangles. In order to avoid that, we need to put everything into one single list. So we're going to put all these hexagonal shapes into one list, and then this component takes it as a whole and put a single rectangle around the entire thing. So now I want to use a component that let me define the different edges, and that is the deconstruct B-rep. So now we have a B-rep here, which is this rectangle, and I want to connect this bounding rectangle to this deconstruct rectangle, and here this deconstruct gives me the faces, the edges, and the vertices. Now if I connect the edges, you'll see it says there are 4 values in this list. So I need to pick list item and say, okay, just for example, pick index 1, which is this, or index 0, which is this. And then when I connect this geometry, the boundary edge to this geometry, then you will see this pattern will be defined based on the proximity of those center points to the points along this edge. If you want to have like a more free form, you can just draw a curve and then pick that geometry as the base to create that attractor point. So that's all for this video.